Hi, Addy. Welcome to lesson number 71. Today we are going to talk about parallelograms. So it's going to be a super fun lesson because we're going to actually learn some really interesting characteristics about parallelograms. But first things first, I want you to get out your multiplication facts. We're going to do 64 multiplication facts and you have 5 minutes to do it, okay? So here we go. Let me get out my timer. Are you ready? You have a pencil ready? I'm going to put on some relaxing music for you while you do this, okay? Ready, set, go. You're doing awesome, Addy. Keep up the good work. Keep up the good work, Addy. You're doing great. Keep it up, Addy. If you're done, you get to just sit and relax. Okay, I'm gonna stop you right there and I'm gonna jump back into the lesson, okay? So here we go. You can put the multiplication aside. Good job doing that. And now we're gonna look at this comic. Okay, this is another Far Side comic. You know I love the Far Side. And it looks like a couple polar bears maybe are looking at this guy running away. And it looks like this one is saying, I lift, you grab. Was that concept just a little too complex, Carl? Anyway, I love it because it's just so funny. Like this guy messed up what he was supposed to do and he's getting chewed out by this other polar bear. It's pretty funny. Like they're talking to each other like people. Alrighty, let's jump into the rest of mental math, okay? And we're gonna have some cute animal pictures to keep us going. The first thing we're going to do is we're going to count by 12s from 12 all the way to 144, okay? So remember, in your head, you're going to be thinking 12 times 1, 12 times 2, okay? And we're going to count by 12s. Ready? So let's do 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144. Were you able to do that with me? All right, sweet. Let's do the rest of mental math, okay? This is a little sugar glider in that picture there. Isn't that cute? Oh, a little sugar glider. Okay, focus. We're going to do 5 times 480. Write your answer. Okay, for B, we are going to do, oh, there's another little sugar glider. This one's jumping. 367 minus 99. For C, we're going to do 8 times 43. And D, we're going to do $10 minus $8.75. If I'm going too fast, you can just pause it, okay? For E, we're going to double $2.25. And for F, we're going to go $250 divided by 100. All right, now this long one. Look at this picture of the chameleon. This is so cool. Man, that bug didn't even see him. It's like if I were that bug, I'd think, man, I just got eaten by a tree. Whew. All right, we're going to start with 8 times 9. That's our number we're going to start with. Now we're going to add 3. Divide by 3. Multiply by 2. Subtract 10. Divide by 5. Add 3. Now divide by 11. What do you get? Alrighty, for H, we're going to hold our hands 1 yard apart and then hold them 1 meter apart. Now, did you go from small to bigger or from bigger to smaller? You tell me. You start at 1 yard and then you go 1 meter apart. All right, let's do problem solving. Problem solving is, remember when we did the factor trees? we are going to do one except kind of in reverse, because look what they give us. They give us this, and we know some of these numbers at the bottom, but these are the unknowns. So we're trying to figure out all of these, okay? So we're going to fill in the missing numbers. Now, remember how you do a factor tree. If you've got a number here, for example, these two numbers have to multiply together to get that, right? So if we have a 2 and a 2, we know that this number must be 4, because 2 and 2 are factors of 4. And then you'll have this one and this one, so you can figure this one out. And I think you can do it from there. So you keep going. I'll let you pause it here, and I'm going to go on to the new concept. Okay, the new concept is, this is a really fun lesson because it's properties of parallelograms. So parallelograms have some really interesting things about them, about their angles and things like that, that make it really cool to do some of these problems. And this is going to come in a lot of, this is going to really come in handy. I'll say that. It'll really come in handy when we do more geometry. This is part of geometry, actually. Properties of parallelograms. Okay, so you remember that a parallelogram has a side here that is equal to this side, and this side is equal to this side, and they're parallel to each other. This one is parallel to this one is parallel to this one, and they're the same length. It's kind of like a square or a rectangle. It could be a square, but a rectangle kind of leaning over. Okay, so that's cool and everything, right? That's cool. But there's also something else that's really cool about parallelograms, and one is this idea. Opposite angles have equal measures. That is so cool, because if you know what angle this is, like if you get out your protractor and you measure this and it's an angle of like 35, then guess what else you know? You know that you know this angle because it's the one opposite of it. So those opposite angles have to be the same. So cool. Okay, and there's more, but wait, there's more. This angle and this angle are opposite each other, and so those must be the same. Whoops, I didn't mean to do that. These must be the same too. Cool, huh? And there's another really cool thing. Okay, so adjacent angles are supplementary. Adjacent means you're sitting right next to that other angle. Like if you're sitting adjacent to Danny, for example, then you're sitting right next to him, side by side. And so if angles are adjacent to each other, they're side by side right next to each other on the same side. So for example, this angle is adjacent to this one, and also this angle is adjacent to this one. But also, guess what? This angle is adjacent to this one. And this angle is, because it's right next to it. So cool, right? That is cool. All right, so here we go. What does it tell us? What do parallelograms tell us about adjacent angles? They are supplementary. So do you remember what that means? That means if you add them together, they have to equal 180 degrees. So if we know this one is 35, then we have to know this one is going to be 180 minus 35. 180 minus 35, that would be 145. Cool, right? That is so cool. And it makes sense because it kind of looks like that angle because it's like bigger than 90, that's for sure. Okay, so that is so cool. Now, with that information, let's jump into example 1. So this is example 1 on your first page, okay? And it says, in parallelogram ABCD, so that's what they called this parallelogram because it has an A, a B, a C, and a D. The measure of angle A is 60. So they tell us that this one is 60 degrees. Okay, now it says, what is C? They want to know this one. Well, these are opposite angles. So what did we say about opposite angles? They have to be the same. So cool. So that one has to also be 60 degrees. Now it also wants to know what is the measure of angle B. That's this one. So B is adjacent to A, and so that means they are supplementary angles, and supplementary angles have to add up to 180. So B is going to be equal to 180 minus 60. So that means it must be 120 degrees. And they didn't ask for it, but we could also figure out D. D has to be 120 degrees too. So cool. That is fun, right? Okay, now this is kind of an idea for a flexible model of a parallelogram. So pretend these are like, I don't know, little pieces of paper, or it could be like rulers, or it could be popsicle sticks that you've attached to each other with these brads, but the brads allow it to move. And so it can like slide, you know, back and forth. What I mean by slide is like this. It can do that. It can start leaning over, okay? So it can lean over. And we can make one of these if you want, and I think maybe we will. I'll decide. You let me know if you want to make one, because I think I'm gonna be home on the day that you're doing this lesson. So you let me know if you want to make it. But what's cool about it is that when you slide it back and forth like that, it tells you some other interesting things about parallelograms. One of those interesting things is this: opposite sides are always parallel and they're always equal. That means if you measure this side right here and you measure this side right here, they're going to be the same length. So that's cool. This is going to be the same length as this length. And the same with the top and bottom. This is going to be the same length as this length. So those little hash marks mean that this is the same as this, and this one is the same as this, because they're the same, okay? The other thing that's cool is they're always going to be parallel. So if you draw a line that's perfectly even with it, those lines will never meet. It's tragic. They have so much in common, but they will never meet. Okay, same with these lines up and down. One here and one here. They are parallel and they're the same length. They will never meet each other. And same if you lean it. If you lean it, then this is still going to measure the same as this. And this is still going to measure the same as this. And they're still going to be parallel lines. See, because we've got this line this way, this line this way, so they will never meet. And this line this way, and this line this way, so they will never meet either. It's so sad. But you also have those really cool things about the angles. So this angle is the same as this angle. And let's do another one. This angle is the same as this angle. So cool, right? And if you take it to an extreme, you can do that, because this is, I didn't draw it very well, but this is going to measure the same as this line, and this is going to measure the same as this. The lengths are going to be the same, and even their angles are going to be the same, even though it's a really tiny angle. Okay, so if those things are the same, what changes when you lean it over like that? So the thing that changes is the area. So if you take the area inside a parallelogram, and the area is this space, remember that an area covers a space kind of like a tablecloth covers it, or carpet covers it, or something like that. This is the area. And you can see that the area, the more you lean it, the smaller the area gets, until it gets to almost nothing when you lean it. I mean, you could even take it all the way flat and then it would finally get to nothing. But the area is changing. It's not the same from one to the next. But there is something that stays the same, and that is the perimeter. The perimeter is, you know, if you're a little ant, like right here, if you're a little ant, there's your little legs, and you have to walk all the way around. So the lengths don't change, and so that means the perimeter is not going to change. And if you measure the perimeter around this one, it's going to be the same, and that makes sense because you're not changing the length of your popsicle sticks, you're just leaning it. But the ant is still going to have to walk the same distance if it's walking all the way around. So the perimeter does not change, but the area inside of it does change. So that's cool. And that leads us to this equation. And notice that this equation is in a thought cloud. And what does that mean? It means you have to memorize it. You have to put this equation in your brain. You have to know it backwards and forwards. You have to be able to figure out every problem that uses this equation. It should be dripping off your tongue. So you can know this. It's area of a parallelogram. That's a little parallelogram there. The area of a parallelogram is the base times the height. But there's one thing to remember. These are the perpendicular measurements. You're not going to measure the slanty height. No, you don't measure that height. Who cares about that height? That height can change. Oh, actually, no, that height doesn't change. That height doesn't change. But this one does. And this is the one you want to know because the area, okay, that makes sense. The area is going to change. So this height is going to change. And when the height changes, the area changes. Okay, but the base is not going to change because that's like the length of a popsicle stick. It's going to stay the same, right? Okay, now we got it. Now we got it. So the area of a parallelogram is the base times the height. But the base times the height are the perpendicular measurements. What do we mean by that? That means that you're going to measure one of these bases, and then the height is the distance from one side to the other side, but only if it's a right angle. So it could be this distance in the middle, but they might also be a little tricky and give you like this distance, okay? And this would be the height right here. That could also be the height. So you could use this distance, which is the same as this distance, but it's the base times the height. That's how you get the area of a parallelogram, base times height. So area of a parallelogram is what? Base times height. It's a lot like the area of a rectangle, base times the height, length times width. And this activity is supposed to prove that to you, okay? So this is going to be really cool. And you can try it with graph paper if you want, but I'm going to do it for you here. And if you don't get it, because I'm home on the day that you're doing this, we'll do it together, but I think you're going to get it, so maybe you don't have to do it. They want us to get out some graph paper, and the first thing they want us to do is draw two parallel lines, like this. So I drew a line right here and a line right here, and these lines have the same length, because if you count the squares, it's 1 square, 2, 3, 4, 5, 6, and this one is 1, 2, 3, 4, 5, 6. Okay, once we draw two parallel lines like that, then we hook them together like this. Okay, so I kind of did it already, but whoops, we hook this together and we hook this together, and now we have made a parallelogram. And you'll notice that the base of it is 5 units long, 5 units long, and the height of it, and remember height, when we talk about the height of a parallelogram, we are talking about this distance from the top parallel line to the bottom. It's not this slanty distance, okay? So that distance from the top to the bottom is going to be 4 units, 4 units high. So it's 5 units long and 4 units high. Now, what they would have you do with your graph paper is cut this thing out, okay? So they want us to cut this thing out, and then what we're gonna do is you take this piece that you cut, well, let's see if I can do it. You take this piece and you move it right here. And then what happens is that you have just turned your parallelogram into a rectangle. The rectangle is this guy. Cool. Whoops. Let's fix it. Let's fix my rectangle. I want to bring this up. It won't let me. Oh, it wants to make a square. Okay, I'll just do it again. Okay. And all right, it's not perfect, but whatever, close enough. Okay, now if you were to measure the area of this rectangle, you would do area equals length times width, which would be equal to 4 units times 5 units, and you would get 20 units. And this is the same as the area of this parallelogram because you didn't change the area. All of this inside stuff is the same as this inside stuff. You just cut it and change the position of it. So now it makes sense that the area of a parallelogram is the base times the height, because if it were a rectangle, it would be the same as the length times the width. Cool, huh? That was actually pretty fun. I actually like that. Okay, now let's do one last example and then we are done. Fini. Sweet. All right, so example 2 says find the area of this parallelogram. I told you they could be tricky sometimes. They put the height way out here, but it's okay because that's still the height. This is the same as a dotted line as if they drew it there. As if you cut here with scissors and move that over, it would be just like that one. So the area of this parallelogram. Now, when they ask you to find the area of a parallelogram, you are going to pull this equation out of your beautiful brain, right? Pull this equation out of your beautiful brain. It'll drop right off your tongue and you'll be like, oh, I know the area of a parallelogram. It's the base times the height. This is the base. Which one's the height? Okay? Some of your friends, if they're not as smart as you, are going to choose this, but that is wrong. Okay? You don't want the slanty height. No, you want the perpendicular height, the one that's at a 90-degree angle. So you're going to choose this one. So the base times height is 6 centimeters times 5 centimeters, and the answer is 30 centimeters squared, because that's the units for area. Okay? Sweet. That was super fun. Okay, guess what? Hang in there, baby, because that was the whole lesson, and now you get to go do your homework. Okay, love you, Addy. Hope you have a great time doing your math today. Okay, bye.